Today we're going to talk about normal distributions, and we're going to do that with tech and do a couple of practice problems. And we're also going to talk about how we can tell if something is normal or has a normal distribution. If you're watching this version, this is the version for TI-89. These are the directions, so why don't you go ahead and pause so you can take a second and write these down, and then on the next slide I will show you how to do this on the TI-89. Okay, so I'm just going to go to the home screen so you can see how all this works. So I'm going to go to Flash Apps and Stats List Editor, which is the last application that I was on, so I can just press Second and Apps right there, which is super helpful. So Second Apps. So then what I'm going to do is I'm going to go to this new section here called F5 Distribution. So I'm going to press F5. And if this is finding area using data, so this is how to find my percentile, I'm going to go to the normal CDF. Don't use PDF ever. We will never use that one. That is not the one that we use. You will get a wrong answer every time. CDF is for a range of values, and that is what we will always do. So we're going to do normal CDF and hit enter. So then it's going to ask us what values do we want. So let's say that we're going to do that gerbil problem that we just did. So we want to go from what's the possibility that we could have a gerbil that weighs less than 20 grams. So basically I want the lowest value to be the most negative value I can have. So let's press negative, and you could just enter 1 and a bunch of zeros, or you can hit diamond catalog and just hit infinity. So then I'm going to say my upper value is 20, and I'm going to enter in the mean for my gerbil mean, which was the mean weight was 25, and the standard deviation was 3. And then I'm going to go ahead and hit enter, and enter again. And then I get my CDF of 0.04779, which was slightly different from the one we got with the table because this is an estimate, or the table is an estimate, and this is a more precise value. Now that you've done this with your calculator, we need to make sure that you show your work. So I'm going to suggest that every time you do this, you make a z-score. Even though your calculator is doing this for you, it's just, you're going to get more points this way. So a z-score, I would say, okay, our value is 20 minus our mean of 25 divided by our standard deviation of 3. And then I'm going to make a curve. And my curve is going to be like this. This is probably 25. So we're looking at the value of 20, and I'm going to shade this region to show us that we're looking at less than 20. So then I need to say, well, how did I get all this value? And notice I didn't say equals on the z-score. I'm not even going to bother to calculate it because what I need to say now is how I got this. So I'm going to say using tech, I did a distribution, and then I did normal CDF, and then I need to say that my lower was negative infinity, and then I need to say my upper was 20, and I need to say my mean was 25, my sigma is 30, and I got an area of 0.048. Work shown. So then this is how we would find an area or a percentile if we're given z-scores instead of actual values. So if we're given z-scores, again, it's going to be the same thing that we did before, only we're going to enter mu as 0 and sigma as 1 because that's the standard normal distribution. And since we're using z-scores, we now have a standard normal distribution. So I'll give you a sec to pause so that you can write these instructions down. Okay, so you should be on, you should already be in your stats list editor. So we're going to do the F5 again distribution. So I'm going to press F5. I'm going to go down again to normal CDF, just like I did before. And now I'm still trying to figure out what is less than before, but let's say I have a z-score now of negative 1.67, and I'll just say that. So I want to see what's the possibility that something could be less than a z-score of negative 1.67. So less than is going to be negative infinity. And instead of a mean of 25, because it's a z-score, my mean has to be 0 and my standard deviation has to be 1. And then I hit enter. And tra-la, I get the same answer, 0.047. Now I don't have to have the z-score to find the area. I can use actual values as well. So again, if I go to F5 distribution, I could go here to our friend normal CDF, and then I could say, oh, hey, I want to find what the normal CDF is between 20 and 26. So my lower value is 20, my upper is 26. I'm going to use, instead of 0 and 1, because I have actual values, I'm using a normal distribution, not standard normal. So I have to use my mean of 25, my standard deviation of 3, and I'm going to hit enter. And then, oh, look, I get 0.58. So I can do it this way as well. I don't have to have the z-scores to find percentiles in area. These are the directions for what you would do if you actually wanted your calculator to graph it for you instead of you graphing it yourself. Now, I don't actually use this feature very often, but I wanted to show it to you nonetheless. So why don't you pause and write these directions down. Okay, so I'm still in Stats List Editor. I'm going to go to Distribution again, F5. That's where we're living all day today. And in this chance, I'm going to go to Shade. I'm going to throw some shade down here and do Shade Normal. Just a normal amount of shade. So my lower value is negative infinity. Let's try that 20 value again, just for funs. Okay, so, or maybe I want to do between two values. Let's try that. Let's try between 20 and 26, because I want to see what that shade's like. And I'm going to say my mean is 25 and my standard deviation is 3, because I'm using actual values, not z-scores. So I'm going to say, yes, I would like it to auto scale, and hit enter again. And then it draws a pretty picture for me of the distribution. But what's really nice about this is it also gives me the area. So that's my percentile between those two. So it's 0.58. So tells me my lower, tells me my upper, shows me the picture, but then also gives me my percentile. So these directions tell us how to find, basically how to find the z-score from a percentile, or going from inside of the table out. So if I want to find a z-score for something, which is something, honestly, I'm going to be real, I rarely do, I would go to F5 distribution, inverse normal, and then I'm going to enter the area as mu equals 0 and sigma equals 1. However, if I want a percentile and I don't have the z-score and I just have the normal distribution, I can enter in the mean and the standard deviation for the normal distribution instead. And I'll show you how to do that on the calculator. Okay, so I'm here in Stats List Editor. I'm in F5 again, distribution. And I'm going to go here to inverse this time. So inverse means I want to go inside the table to get a value. So I'm going to arrow over and go inverse normal, because that's super important. And then I would say, okay, what's my area? So maybe I want 90%. And you have to remember that your calculator cannot it can only go from your value to the left. Your calculator cannot go to the right. So you have to think in terms of what is the percentile to the left. That's the only one that you can enter into the calculator. So if I want what value are 90% of the gerbils weigh less than, like what weight do 90% of gerbils weigh less than, then this might be my problem. If I want the z-score, I would say 0 and 1 and hit enter. And then I would get a z-score of 1.28. However, if I wanted not the z-score but the actual value, then I could go to inverse normal. And then I would say, oh, 25 is my mean, 3 is my standard deviation. And then I could get, oh, it's 28.8, that 90% of gerbils weigh equal to or less than 28.8 grams. But what if I want the right side, not the left side, calculator? Well, then you have to do some thinking. So if I said I wanted to know what the highest weight for 25% of gerbils was, right? I might be like, okay, so I'm saying that 25% is here. That's 0.25. I can't enter 0.25 into my calculator. I can only enter this value. So then I have to go, oh, 1 minus 0.25. This value must be 0.75. So 0.75 is going to be the area that I enter into my calculator. So what have we done so far? The answer is a lot, and we're almost done with the chapter. So this is what we've done so far. First we were able to find an individual's percentile. Then we could turn that into a cumulative relative frequency graph, which is a graph of the percentiles. Then we learned how to transform data, how addition, subtraction, or multiplication or division are affected, how they affect shape, center, and variability in a distribution. We learned how to locate an individual in a distribution using a z-score. So we learned how to make z-scores and the formula for that. We learned the 68, 95, 99.7 rule, aka the empirical rule, to estimate normal percentiles. Then we learned about standard normal distribution. So basically, we learned about the fact that I can have a distribution of z-scores, and then my mean is 0, and my standard deviation is 1 when it's standard normal, aka z-scores. We learned how to use table A to turn a z-score into a percentage, and we did that with tech as well. And we also learned how to use table A to turn a percentage into a z-score, and we learned that with tech as well. So let's try an example of this. This was actually the first statistics teacher at Holy Names did this for me when I was pregnant, so that she actually wrote this problem about me, which I love. So a pregnant woman is due in January. She has asked the stats class to help her estimate the length of her pregnancy based on the average length of pregnancies. The approximate normal distribution of pregnancies from conception to birth has a mean of 266 days and a standard deviation of 16. Might she give birth early? This was my big question. What percentile is a pregnancy that lasts 8 months? Might she be about on time? What percent of pregnancies last between 8 and 9 months? And then I was very specific there. And then might she be late? How long did the longest 20% of pregnancies last? These were all very important questions to me. So let's take each one at a time. So let's take the problem of might she give birth early? What percentile is a pregnancy that lasts 8 months or 240 days? So let's start with what we know. We know that the mean is 266. We know that the standard deviation is 16, and we got that from the previous slide. Okay, so the first thing I want to do is I want to draw a distribution. So I want to go, what's the possibility that could be less than 240? So my x value is 240, and I want to know what's less than that. So I actually took a picture because it's easier for that than drawing. So this is what I'm looking at here. So this is what my distribution would look like. So first step, write down what we know, then write our distribution. Then we need to come up with a z-score. So we're going to say, okay, our z-score is going to be 240 minus 266 divided by 16. And when I do that, I get a z-score of negative 1.63. So I need to find what the percentile is for z-score that is less than negative 1.63 because that's what I shaded in. So I'm going to show you how to do this on the table. So let me bring the table up here. So I'm going to find my z-score of negative 1.63. So I'm going to go to negative 1.6 and 3, and so that looks like this to me. So 0.0516. Okay, so if I were to answer this in context, I would say about 5.2% of pregnancies last less than 240 days. Which to me meant, dang, I am probably not going to be early. Okay, so let's take a look at this second problem. Might she be about on time? What percent of pregnancies last between 8 and 9 months, between 240 and 270 days? So first thing I need to do is write down my givens. Mu equals 266, and the standard deviation is 16, and x, my first x is 240, and my second x is 270. So I would probably pause and be like, wait a second, what am I doing here? I better draw a distribution. There it is. So it's between 240 and 270, which means I'm going to need 2 z-scores and 2 percentiles. Luckily, we've already done 240. 240 we found had a z-score of negative 1.63, and then we found that the percentile for that z-score being less than negative 1.63 was in fact 0.0516. So we've got info for there. We need to do 270. So we're going to do a z-score for 270. So we're going to say, okay, that's 270 minus 266 divided by 16. And that gives us a z-score of 0.25. So I'm going to look at my table and look at 0.25. So looking here, I have 0.25. Hey, right there, 0.5987. So that equals 0.5987. Now I'm not even close to done. That is all of this region, right? And I know that 0.0516 is all of this region. So I'm going to have to subtract 0.5987. I'm going to have to take away from that 0.0516. So when I do that, I get 0.5471, or roughly 55%. So I might be like about 54.7% of pregnancies are between 240 and 270 days. So C is a bit of a tricky one. Might she be late? How long do the longest 20% of pregnancies last? So, okay, let's figure out this one. Again, I can do this. Mu equals 266. My standard deviation is 16. And now I have a percentile. I have 20%. So the first thing I'm actually going to do is draw a distribution here. So I want to say the longest 20%, which means that's 20%, but on the right side. And I can't do anything unless it's on the left side. So I have to do my fun math and go, okay, well, 1 minus 0.2, that's easy, that's 0.8. So what I'm really looking for is a percentile of 0.8 is what I'm going to need to calculate. So I'm going to go inside the table. I'm going to show you how to do that on the table. You're welcome to try your calculator. So on the table, I'm going inside, and I'm looking for 0.8. So this is pretty close. 0.7995, that's pretty close to 0.8. So if I go backwards here, I see that I have 8 and I have 0.04. So that's going to be 0.84. So the value for my z-score is going to be 0.84. Now I showed you how to say that you were doing this with TeX. If you're not using TeX and I just say this, they don't know how I did this. So I need to say that I'm using table A. Using table A, I got this z-score. Well, that's great. I want to know what the longest amount of time is though. So that, all I have is a z-score. So now I need to solve for my value. So I'm going to set my z-score equal to the formula of value, right, minus my mean, 266, divided by 16. So I'm going to multiply both sides by 16, and this side is going to be 13.44, and this side is going to be x minus 266. Okay, so now what I've done is I'm going to add 266 to both sides. So that's going to be, let's see, x equals 279.44. So then I could write this in interpretation. The longest 20% of pregnancies last approximately, look at me abbreviating, 279 days or more. Which was 100% the case for me with my first pregnancy. Lucky me. Now, z-scores are really great. We love to turn things into z-scores so we can find percentiles, and it's fabulous and it's wonderful, and we can only ever do that if we have an approximately normal distribution. If we do not have a normal distribution, we cannot do z-scores. So a key part is figuring out, hey, do I have a normal distribution? Now this is super tiny on the AP exams. I'm not going to devote a whole lot of time to it. So I'm going to show you how one would do that, but letting you know that one rarely does this. Okay, the first method is what they call look and see. For this method, I would graph the histogram and I would be like, hey, is that unimodal? Is that look symmetrical? Then it's probably approximately normal. This is the second one. Doesn't match the empirical rule. I'm going to be honest. This is so much math, I've never done it. But I wanted to show you how one would do it if one wanted to waste time in this manner. So I could take the mean and add one standard deviation to it. So here's a sample mean and standard deviation, and then I could find what that range is, and I could find how many values are in that range and be like, oh, like that's 76% of the data, and 2 standard deviations, that's 77. That's pretty close to the 68, 95, 99.7 rule, but nobody's got time for this method. The one that's most commonly done is calculating a normal probability plot. And for this one, I'm just going to show you on the TI-89. You can look for the 84. You can look it up on the 84. Basically, what you need to do is go to Stats List Editor and hit F2 plots, normal probability plot, and then you input whatever list you're trying to do. And then you just hit zoom on the data. This is what a normal probability plot should look like. And if everything's normal, you're seeing a nice straight line. Here's not normal. If I were to draw a line here with most of the data, you would see that all of these are heading off towards the right. That's because it's skewed towards the right. So this is not normal. This is what the normal probability plot would look like on your calculator, and another one with Fathom. For the most part, you will never have to draw a normal probability plot, nor will you ever have to do one on your calculator. I have not seen an AP exam question that asks you for this. I have, however, every 3 or 4 years, seen an AP exam that puts up a normal probability plot and asks you, is this normal? that's pretty much the extent of what you need to know with normal probability plots or even assessing normality. Is they'll give you a plot and they'll be like, hey, is this normal? And you'll have to be like, well, is it on a straight line? Sure, it's normal. Otherwise, no. I don't anticipate that this is something that you're going to see. They have diminished it greatly on the AP exam, but I thought I'd prepare you nonetheless. Most of the time when you see a problem, they will tell you this is approximately normal, and then you know that you can use a Z-score. And that's it. Have a great day.